All right, it's time to see how we can derive the aggregate demand curve. So far, you've seen the IS curve. We derived that in class. That tells you from the Keynesian cross, where we made planned expenditure equal actual expenditure and solved for Y. We've talked about that. And then the LM curve, this comes from the money market. That's where money supply equals money demand. We come up with this relationship. So it's the intersection between the intersection between the IS curve and the LM curve that lead to the aggregate demand curve, where we're trying to get aggregate demand curve in terms of price and output. So we're trying to get a relationship between the price level and the output, where price level is right there. Okay, so our goal is we're going to try and draw this in terms, we're going to try and solve this in terms of Y, because really we want to see how Y changes when P changes as we go through, okay? Okay, so first step is we need to take the money market and solve it for R, because we're going to want to put R into the IS curve, because, and why am I solving it for R? I know from the ISLM diagrams together that they are in RY space, okay? And so R is the endogenous variable. So if I solve this one for R, I'm just bringing the R over to the other side, and I took M to the other side using a negative number, and then I divide everything through by this lambda, and we get this expression right here. Okay, so that's R in terms of the money market. Next step, we move down and we put this R that we've solved for into the IS curve, right there. Okay, so I've just repeated the IS curve in its pieces, and then where R was before, I've substituted in for the LM curve. All we're doing from this point now is algebra. Notice I have a y on this side of the equation and a y on this side of the equation, and I want to try and get to the point where I've got y equal to just exogenous variables on the left-hand side. So I distribute through the negative h over 1 minus b to each piece here, and that's where I get this piece, and this piece. Keeping track of the negative signs is important. Okay, now I've got this y here that I don't want here, so I'm going to bring it to the other side. So I've got y plus h over gamma, h times gamma divided by lambda times 1 minus b times y. Everything else stays over there. So this piece, this piece, this piece, this piece, this piece, and this piece all stay over here. Now let's figure out what this looks like. Well, I've got a y and a y, so I'm going to pull them out, and I pull the y out, and it's 1 plus that thing that was in front of the y before, just an algebra step there. I'm going to now put those things together. So I take that they have a common denominator, so this 1, I'm now just saying lambda 1 minus b divided by lambda 1 minus b, because that is 1. But now I have a common denominator, so now that I have a common denominator, I can add the top and keep the bottom the same. So that's the top added and the bottom's the same, and that is what y is multiplied by. Okay, so now let's go back to the whole problem. This is the piece that was on the left-hand side. I want y by itself, so I divide by the reciprocal of this. So I'm flipping what's in front around, because that's dividing by the reciprocal. Thus it cancels on this side and shows up on this side in a reciprocal form times everything that's on the left-hand side. All right, this next step then is just the algebra of moving this piece through to each piece on the left-hand side. Okay, so we get these fairly complicated expressions. Notice the 1 minus b's cancel a lot along the way. So the 1 minus b in the a, the 1 minus b in the z, the 1 minus b in the with the tax, those all cancel out. All right, so those 1 minus b's cancel in all cases. That's why it's disappearing, and you're mainly ending up with lambdas or whatever else was above there in those cases. Okay, now notice I put a out and this sigma thing out as well. Okay, so this is what I've been aiming for. This is my aggregate demand curve. It tells me a relationship between y and p. Look, there's p. And yes, p's on the bottom, so it's nonlinear, but that's okay, because I can see here that as p gets bigger, y goes down, right? That's that negative relationship that we're looking for in an aggregate demand curve. As we look here, this is p and this is y. Okay, so it's a downward sloping aggregate demand curve. As p's getting bigger, y is getting smaller. And so we've got that here. What are all these rest of these pieces? Well, these are my shifters. Shifters, 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 shifters. And I circled this because the M can be a shifter as well. Because you could think of this as M times 1 minus 1 divided by P and keep them separate. Okay, so that's really helpful. The reason I've kept this all separate and nitty-gritty like this is, number one, I can see what's affecting, what are the sensitivities that are coming into play when I change A, or sigma, or T, or W, or M, or G. So I know what's causing the sensitivities, and now I can easily do the total differentiation. Okay, so just for simplicity, if I substitute what's on the bottom by theta just to keep things simple, that's just a rewrite of that with the theta. And now I can do the total differentiation, and you can see how each one of these shocks might affect output. And so this is a repeat here. That's y written in its more simpler form. So if I want to know how y changes, I just need to take the total differentiation. It depends on how A changes, which is a consumption shock. Remember, that comes from C equals A plus B minus B times Y minus T. It could happen because of an investment shock. That's where that Z come from, because that was I equals Z, Z minus H times R. It could be a W. That's a money demand shock. That came from the LM function. That was just what was hanging out in front as a money demand shock. It could come from changes in taxes, which came in through the consumption function. Y can change if I change government spending, and Y can change if I change M. Really think of that as just M, because P is the endogenous part that's causing that line to go upward and downward. Okay, so now all I need to do is just find out how all these things changed, plug them in. These are all going to be numbers, and so it's just a sensitivity in the front. But now I plug it in and I can see how Y changes when I change any of these. Now to see how my other endogenous variables change, I come down further. This comes from the LM curve, the LM curve that solved for R. So R was equal to 1 over lambda W, gamma over lambda Y, minus 1 over lambda times M over P. So now I can just come in here and say, all right, well, the change in R, just do the total differential of that, is the function of these things. Okay? Now, R is always going to change if Y changes. So whatever number I've come up from this equation here needs to be substituted down right there. And then if something happened to W or M, I put them in as well to see what happened to R. Okay, what happens to consumption? Well, I go straight to the consumption function. A plus B times Y minus T. So it's a function of how A changes, how Y changes, and T changes. The change in Y that I found in step 1 needs to be plugged in there. And then if there was a change in A or T, I put it in as well. How's investment change? Again, go straight to the investment function, Z minus H times R, and then I've got to use how R changed here to plug in there, and then if a Z changed, I put it in there. So I know exactly how all of those things can change. Okay, so it's very simple with total differentiation. The slide here is just the graphical example of what we've seen. I take the Keynesian cross, and I use this to derive the IS curve. Okay, so changes in here that have to do with something other than the interest rate move the IS curve. Changes in here that have to do with the interest rate create the IS curve. The LM curve comes from the market for money. Okay, and it's and so this line was created by changing Y and letting R fluctuate. But anything else that changes in here is a shift in the LM curve. And then we combine the IS and LM. That helps us find the interest rate. But we're interested in finding the aggregate demand curve. So the aggregate demand curve comes from changes in P. Now notice, P changes real money supply, so it changes the LM curve. So really, what we're doing is we're trying many different P's, and that's moving this LM curve up and down depending on what the P is, and we're mapping where it intersects the IS curve. So if you think about it, the aggregate demand curve is just a mapping of the IS curve. Okay? But shifts in anything else that shifts LM or IS outside of P will cause a shift in the aggregate demand curve, and that's what shifts it around, everything except that. Okay? So what are the steps that you go through? These are your steps. You have to identify the shock and decide whether it originates in the Keynesian cross or the money market. If it originates in the Keynesian cross, then you're going to change the Keynesian cross and you're going to be shifting the IS curve. Okay? But before you shift the IS curve, go back and look in the money market and see how the money market has been affected by the change in the Keynesian cross, because that's going to be your movement along the LM curve. Okay, if it originates in the money market, you're going to shift the LM curve, but you need to go back and correct the Keynesian cross to see how you moved along the IS curve. Okay, so that's how you get movements along and shifts. The shift comes from where the original shock originated. The movement along comes from how the secondary market was affected. Okay, then once I've shifted IS or LM, I shift the aggregate demand curve to match that shift. Okay, and we will go through this example of government spending in class, but you have it all here with the story, so that you can go and review it and compare it to your notes. But just a real quick, I want to just talk about this last point here. We see that if you change government spending, output's going to change. Okay, and it's going to change by this much. Now I can see the things that play into how output's changing. Output's changing depends on how sensitive the interest rate is to the change in money demand. That's where lambda came from. It's the slope of the liquidity preference line. It also depends on your marginal propensity to consume. That's when you've gone back up into the Keynesian cross and seen how much there's the movement, how that movement in the Keynesian cross intersects with the 45-degree line. It also depends on H, how sensitive investment is to changes in interest rates. That's bouncing back between the Keynesian cross and the money market. And lambda, how sensitive demand liquidity preferences are to changes to Y. So you can see it all work together, and we'll do that in class. But here's your breakdown of the aggregate demand curve, and we'll work through some examples.